In this session, we're going to discuss tension and compression in a bar or a rod made out of two different materials. Material 1, material 2, and this is subject to either tension or compression. So to solve this problem, we're going to use two types of equations that we have been talking about. We write the equilibrium equation, where we basically say that the total force that is contributed by material 2 plus the total force contributed by material 1 has to equal the total force that's applied on the member. On the other side, we have the compatibility equations, which basically state that the total deformation of this member must be the same to the deformation experienced in material 2 and in material 1, because they all deform the same. Right? So if this is the bar, and this is from looking at it sideways as a section, and we have material 1 and material 2, when this member deforms, they both deform the same amount. So that's what compatibility means, right? Some kind of relationship between deformations. So we need to use these two equations to solve for the two unknowns, P1 and P2. So if we do that from this equation here, we can find that P1 will be, or rather P2 will be A2 E2 divided by A1 E1 times P2. So this P1, sorry. So this gives you the relationship between P2 and P1, and then that can be substituted in here to solve for P1. This boils down to this. And finally, we obtain the expression for P1 by inverting. So this tells you that the force contributed by material 1 is a proportion of the total load, and that proportion, that ratio, is the axial stiffness of material 1 divided by the sum of the stiffnesses provided by material 1 and material 2. We take this P1 and put it in here, then we can solve for P2, which gives us an analogous relationship that looks like this. So we get an expression for P2, which similarly to P1 is the axial stiffness of material 2 divided by the axial stiffness of material 1. So this is a typical result, and this would be what we would call a system that is operating in series, where the deformations are the same and the force, this will be a material that's operating in parallel, where the deformations are the same and the forces add, right? So, parallel systems. And if you had more than two materials, let's say you had 3 or 4, the formula would remain the same. The axial stiffness of one divided by the sum of the axial stiffnesses. So in general, it would be something like the force in material I would be AI EI divided by the sum of AE of all the materials, right? From 1 to n. So you could have a column with 3 different materials, and if they have compatible deformation, the same idea holds.